Good evening, Titans. This is Mr. Sturts. We're now on lesson 5.3. We're still solving systems of linear equations, but this time we're going to use a method called elimination. So we've had solve by graphing, we've had solve by substitution. Now we're going to solve by something called elimination. A little vocab word there. We have coefficient, which is simply a number located directly before a variable. So if we have something like 3x, this 3 is our coefficient before our variable x. Okay, we have 4 steps to solve by elimination. The first step is we're going to multiply, if necessary, one or both equations. Sometimes we don't have to multiply any of them, by a constant, so we can get one of the variables, either x or y, to eliminate itself. Okay, and we're going to eliminate by adding the two equations together. When we do that, hopefully we'll get one of the variables to eliminate. Okay, step 3, we're going to solve for either x or y after we eliminate one of them. Step 4 is just like section 5.2, we're going to go ahead and substitute back in to the other equation, one of the two, to solve for that other variable x or y. In the end, we're going to get a solution. We're going to get an ordered pair, just like the previous couple days. Alright, let's go ahead and do an example here. So first step, we need to multiply one, both, or neither of them by a constant to get a variable to drop out. If we look at the y's here, okay, when we add, if we have opposite signs there, a positive 2 and a negative 2y, when we add them, they're going to eliminate each other. Okay, but look at the 3x and 3x, we're going to get a 6x. Again, positive 2y and negative 2y, those just cancel each other out. Equals 4 plus a negative 4 is 0. Okay, then if we go ahead and divide by 6, we know that x is going to be 0. 0 divided by 6 is 0. Alright, we have our x value. Let's go ahead and substitute it back in. Doesn't matter which one. Pick the easier one. Let's pick the positive one. Okay, and we're going to substitute that in for x there. Okay, so x equals 0, so 3 times not x but 0 plus 2y is equal to 4. Okay, do the math now. 3 times 0 is 0. We're left with a 2y equals 4. Divide by 2 on both sides, so y is 2. Okay, and that's our solution. We get the ordered pair 0, 2. That's our solution to that system of linear equations. Alright, let's look at another example here. This time, it's not quite as simple. This is where we need to multiply by one or both. We need to multiply one or both of them by a constant because we don't have a variable that's going to drop out. They don't set us up on this one. So what we need to do is figure out which variable we can drop out, which variable we can eliminate easily. Again, we need opposite signs. Let's look at equation 1 here, and let's look at the y variables. If we multiplied that whole first equation by 2, and we distributed there, we would get 2 times 3y is going to be a positive 6y. Okay, so let's look what happens here. If we distribute to everything, okay, got to distribute to everything, we're going to be left with a negative 20x plus a positive 6y equals a positive 2. Okay, this is now our equation 1. Okay, now let's rewrite our equation 2 right below it, just like it was in the problem. Now we can go ahead and eliminate. Let's add. Okay, look here, we have our 6y's and our negative 6y's. Those are going to drop out, but we're left with a negative 25x if we add there. Positive 6y, negative 6y, they cancel. They eliminate. Equals 25, divide by a negative 25 on both sides. We're going to be left with x equals a negative 1. Alright, the hard part's done. Now we substitute our x variable back into either equation. Alright, if we pick, let's say we want to use that bottom equation this time. Let's substitute x in for x in equation 2. So negative 5, not x anymore, but a negative 1, minus 6y equals 23. Multiply there, negative 5 times a positive 1 is a positive 5. Two negatives equal a positive, minus 6y equals 23. Subtract our 5, we're solving for y. Negative 6y equals 18. Divide by a negative 6. And y is going to be equal to a negative 3. Okay, so there's our Ordered pair, we have -1, -3, and that is our solution to that system of linear equations. Alright, here's a couple to practice. Let's do one together. Let's just do number 1 together, and then I want you to try number 2 and 3 on your own here. But look, they already set us up nicely here, so we can go ahead and add because we have a +3 and a -3 there. So those eliminate. We're left with a 6y equals 12. Divide by 6 to solve for y equals 2. Substitute that value into either equation. Let's pick the top one because there's no negatives there. We have 3x plus 2, not y anymore, but 2 equals 7. Do the math here. 3x plus 4 now equals 7. Subtract 4, subtract 4. 3x equals 3. If we divide by 3, we're going to get x is equal to 1. And there's our solution. 1, 2. And there's our answer using elimination. Alright, let's do one more example. This is a little application problem here. Let's look at, we have a business with 2 locations. They buy 7 large vans and 5 small vans. Alright, so let's go ahead and make our variables. Let's say x is our large vans and y is our small vans. Now we need 2 equations. Okay, it says location A. So location A receives 5 large vans. So that means 5x, x is our large vans, and 2 small vans. And that total cost is $235,000. Okay, there's our first equation. Now, location B, they say, receives only 2 large vans and 3 small vans, and that's $160,000. Okay, what we need to do is we need to figure out the cost of each type of van. We need to get a value for x and y. So let's use elimination here. Notice they don't set us up nicely at all here, actually. We need to really multiply both equations by a number. Okay, because we can't take just A and multiply it by a number to get something to cancel out with B. Okay, so let's go ahead. We need to multiply, let's see, let's try to eliminate our y's. Okay, if we eliminate our y's, let's multiply, I'm going to write it over here because there's not room on the left. This first one by -3, that's going to get our y's to a -6. So to get to a +6 on the bottom equation, let's multiply by a 2. Okay, we need to distribute this to everything in that equation. So what equation A turns into is going to now be a -15x. We're distributing that -3 minus 6x is equal to, if we do the math there, it's actually -$705,000. Okay, now rewrite equation B. If we distribute the 2, it's going to turn into a 4x plus 6x. There's our eliminated variable. We got opposites there. Equals $320,000. Okay, now let's eliminate. Let's add. So we're left with a -11x. Those eliminate each other. Equals, if we do the math there, we get -$385,000. Solve for x, divide by -11 on both sides. So x is going to be equal to $35,000. Okay, that's the cost for one large van. Now we need the cost for small vans, so let's substitute that in to either equation. Okay, let's go into our original equations. It really doesn't matter which one. If we pick that top equation, plug that 35,000 in for x right here, we're going to have, I'm going to write kind of small here, 5 times now 35,000, because that's our x variable, plus 2y equals 235,000. We need to solve for y now. If we multiply there, we get 175,000 plus 2y equals 235,000. Big numbers. Okay, if we subtract 175,000 from both sides, we're going to be left with 60,000. So 2y is equal to 60,000, almost there. Last step, we're going to divide by 2. So we're left with y is equal to $30,000. Alright, and that's our value, or our price for a small van. And that's our solution. Okay, we have the ordered pair 35,000, comma, 30,000. Okay, the price of the large van's $35,000, small vans are $30,000. And that's using elimination. All right, now that we're done with the notes there, please turn to page 145 in your student journals. Attempt these problems 1, 3, 5, and 8, and we'll check them tomorrow in class. Have a great rest of your night. Thanks for watching.